So, is there any participants who are from outside Karnataka? If I in between my lecture, if I talk in Kannada, is it okay? Or is there any candidates from outside Karnataka?
Sir, I think 2-3 people are outside from Karnataka, including me. I am from Haryana, so
Okay.
I understand Hindi and English.
Okay, no issue. I'll be talking to you in English only. Yeah, and see, remote sensing and JS technology is a recent means it is there in use for last 50 years. So when we were students, it was very in 1960s. It was first developed by the Canadian geographer. Later on, it got into the public domain from 1970 onwards, and 1980, 1990, it was not in a very good. It was under the takeoff stage. So in 1990, 2000, we see tremendous transformation has taken place in these two fields, geographical information system and remote sensing. So I will first explain to you about what is remote sensing, and then let me go to the geographical information system. These are the two different platforms. Geographical information system and remote sensing are two different platforms because these two are having a different area of what we say application, but one is depending upon means geographical information system is depending on the remote sensing, because the remote sensing is a authentic data that will be available to any part of the world, in any part of the world, to any person. So that is um, the most significant aspect of remote sensing. All the days before the launching of the satellites, the data that were to be obtained is from the published sources, that is from the government or the agency which used to maintain the data. So those data we were not sure about what is the accuracy level of that data. Because any data when we wanted to use, we do not know, you just have to blindly use the data, but we do not know whether it is right or wrong. For that matter, anything which is related to agriculture or it is related to any forest resources or mineral resources or whatever the type of the natural resources we have or the cultural phenomena we have, all those information was not available directly to any person. It was through some office we has to approach those office or institutions. From them we were able to get the information. So that was the period. Means when I started my research work also, I was having a lot of difficulty in getting the data for my research work because I used to go and meet the different government officials and the officers involved or the staff involved, and whatever the data that they used to provide, that data had to depend upon, and I do not know whether it is accurate or whether it is recent data or old data. So there used to be any kind of means all sort of lacuna were there. And with the introduction of with the usage of the remote sensing data, now we do not have that kind of a what dilemma or a kind of uncertainty about the data. So I think all of you are able to understand me, because I'm giving an introduction, and this introduction will be the base for the further explanation. So if you could able to understand the basic things, then it will be good for you to understand the coming slides, right?
Yes, sir.
Okay, sir.
So remote sensing is, as the terminology itself clearly states, remote sensing, remotely sensed data without the any human intervention. human intervention, the data that has been sensed by the satellites, the sensors are there in the satellites, those sensors will sense the data, capture the data, and the data will be processed, and later on it will be given to the end user like us. So that is, as you use the remote controller in no, not ಮಾಡಿಲ್ಲ. ಹೋಗುತ್ತೆ. Okay. As we use in our home televisions, remote control, this is also a kind of a similar technology which is from the satellites. The satellites are launched, and the satellites will be in the sky, and from the sky it will be capturing the ground data. So the data that has been captured by the satellites will be processed, and it will be given to the end users. So there is no any intervention of any people, because it is as good as your smartphone camera. If you take a picture of your interest, whatever exactly that is there in the foreground, that objects or the information will be captured by the camera. So there cannot be any kind of a manipulation. So similarly, this is also a authentic or 100% information which is obtained through the sensors. So we are very much advanced in using, means if you use this data, it is nothing but the advanced technology, advanced way of obtaining the data. So the satellites play a very big role here. Means we have the as I already told you, techniques of obtaining information about an object, area, or phenomena from a distance is called as remote sensing. And we have the large region can be observed over time. Sensors can measure energy and wavelengths beyond range of human vision. Records information in real time, means what is not possible from the human side, because if you are given a task of go and find out the survey and come for the whole Mysore region, means even 1 month will not be sufficient, 1 year will not be sufficient. So much of time consumption will be there in order to get the total information of a very large area. And also you can means this information can be saved as real-time information. It is not like what we see, forget, or what we not able to observe properly. All those problems is there. When I go to the field, I may be very much perfect enough to see all the things, but may not be able to get all the information. I may forget or neglect, or may by oversight come without taking some of the information. But in this, it is not like that. So here I'm going to talk about the basics of remote sensing, because I'm not going to deal with technical aspects, because technical aspects is not my field. And technically means what is the sensor and what is the configuration of the sensor. All these things is not required for us. I'll be talking about only the types of remote sensing and what is the data that will be captured from the satellites, and what is happening around the world in India, and what is happening in Karnataka and in my own district. So I'll be just, because I have taken up a lot of research work pertain to my district. So I'll be giving certain applications that I have done using this remote sensing and GIS for contributing some of the findings for my district. So it will be flow from the, as I shown, world to the India level to Karnataka, and my district. So here in this diagram, you can able to see there is a sun, and you find the satellite is D, and another satellite is there, that is so there is one more satellite is E. Here the sun is the main source of energy, main source of energy. Without the sunlight, the reflective wavelength cannot be captured. So for any remote sensing to take place, or remote sensing data to be captured, we need the light energy. So once this sunlight falls on any object, that object will reflect back in different wavelength. That the restricted wavelength will be captured by the satellite sensors. So that is the thing. It is as good as your smartphones. What your smartphones do, when you take a picture, it will capture, means the if you are taking it in a daytime, the sunlight will be acting as the reflector. If you are taking it in a nighttime, you will be using the flashlight. So the light, when it flashes over the object, that object reflects back different wavelength, and that different wavelength will be captured by the sensor in your camera. The same thing happens in the satellite also. When the sunlight falls on an object, that is, see, the A is the sun and B is the sunlight and C is the ground, and when this C reflects back, it will go back. So the D satellite will sense it and it will capture. And once it is captured, it will be sent even to another satellite for further processing, or it will come down to the ground, means ground processing station. So after the ground processing station, it will go to the further processing in F, and from F to G, that is the end user, means the maps and data, everything will be developed here. So here, I think you might have got a clear picture about how this satellite works. The sunlight is the main source of energy, and from the reflected sunlight, the wavelengths that reaches the sensor will be captured, and that will be sent back to the ground station. The ground station will process, and finally it will come in the final product or the output. Is it clear? If you have any questions, you can ask. Otherwise, I'll move on to the next slide. Okay.
Okay, sir.
Okay. So we call it as a electromagnetic spectrum. Means in remote sensing, there is a electromagnetic spectrum. So electromagnetic spectrum, it is it collects the reflected and emitted energy. As I already told you, if it is say, for example, if it is sunlight is falling on a leaf, there is some amount of energy will be absorbed, and the rest of the things will be reflected back, and the reflected back only sensed by the sensor. So here the electromagnetic spectrum means it is the different wavelengths that will be produced by the sunlight. So it will be having the shorter wavelengths including gamma and X-rays, and the longer wavelengths including microwaves and broadcast radio waves. There are several regions of the electromagnetic spectrum which are useful for remote sensing, because we are not able to use the entire electromagnetic spectrum. Only few regions of electromagnetic spectrum are in usage. Still, we had to develop the technology of using the entire electromagnetic spectrum. So here you can find in this figure the wavelengths. So the shorter to longer wavelengths, and the frequency from higher frequency to lower frequency. So in this, you can find the shorter gamma rays are there, X-rays are there, ultraviolet rays, and this is the only visible. This is the only region or the wavelengths which are visible to human eye. Rest of the things we cannot able to see. Can you see? Just only it is from 0.3 to 0.7 we can able to see. Rest of the wavelengths are not able to, means man cannot see through his naked eye. So this is the only visible light or the visible wavelength we are able to see. Rest of the things like the infrared, the microwaves, and the radio waves are not visible to human eyes. So the frequency varies as the higher the temperature, greater the frequency, and lesser the temperature, lower the frequency. So we find that the frequency of the thing will also change according to the temperature, and yeah. So visible spectrum, as I said, that the light which our eyes can see, it is called as the visible spectrum. And it is important to recognize how small the visible portion is related to the rest of the spectrum. I had shown you, it is a very small portion when compared to the rest of the electromagnetic spectrum. It is a very small portion that we could able to see. The rest of the energy or the wavelengths we are not able to see. There is a lot of radiation around us which is invisible to our eyes, but can be detected by other remote sensing instruments and used to our advantage. The main advantage of the remote sensing technology is that what we are not able to see or our human body cannot be able to recognize, we can able to detect through the devices, means the powerful sensors which can detect those either the microwaves or the ultraviolet rays or the gamma rays. All these wavelengths can be detected by these sensors. So through that, we can able to make use of a lot of applications. I'll come to when I speak about the different type of applications, you can able to understand how this invisible spectrum are useful for our development. So already I have shown you, see, this is the visible spectrum, and the visible spectrum, it starts from 0.4 to 0.4 nanometers of wavelength. And this is what we call it as RGB or VIB-GIR. So what we see when a sunlight penetrates through a droplet of water, it acts as a prism, and there will be 7 colors that will be developed from that droplet of water. So either if you put a sunlight in passing through a prism, you can get this VIB-GIR. So we are in short we call the RGB, red, green, and blue. So the blue is the shortest wavelength, and red is the longest wavelength. So as I already told you, it is 0.4 to 0.7 nanometers of wavelength will be there. And the longest visible wavelength is red and the shortest is violet. It is important to note that there is only portion of the electromagnetic spectrum can associate with the concept of colors. So the color combinations is available only within the electromagnetic means visible spectrum. So here as the wavelength means this violet, say actually this RGB is the base colors. This RGB will form all the 7 colors, or you can call 10 million colors, because each color will have RGB. R will be having 256 of different tones of red color, 256 of blue tones, 256 of green tones. So which will produce 10 million colors. But our eyes cannot identify 10, means beyond some 10 types of red you can identify, 15 types of red you can identify. Beyond 10 or 15 red we cannot identify 256. It is only the digitally it can be possible. So also with the green and the blue. So there are 10 million colors that can be identified digitally, and we see our eyes can be able to clearly recognize 7 colors. So and the base colors are this RGB, which forms the 7 colors. So what is the wavelength of this? Violet is the smallest wavelength, and it is 0.400 to 0.446 nanometers, and blue is next smallest, and green is much larger, yellow is much larger, orange, and red is the most larger wavelength. So see, although we see the sunlight as a uniform or homogeneous color, it is actually composed of various wavelengths. The visible portion of this radiation can be shown when sunlight is passed through a prism. So unless and until a sunlight is penetrates or passes through the prism or a droplet of water, we are not able to see that the sun ray has got different wavelengths. So it is only when it passes through the prism, then only we'll be able to notice that. So this kind of a wavelengths are the most significant aspect, which is providing the ground information or the earth information, because each and every object on the earth reflects reflects the different wavelengths. So this different wavelengths library will be created, and based on, as I already shown you, so say for example the violet is having 0.4002 to 0.446. When the certain object produces a very shortest wavelength, that will be noted as a particular object. So it is say for example, hypothetically I'm talking, we can say that it is a banana plant. So blue is reflecting another tree like mango is reflecting blue wavelength. Green is reflected by another tree. So likewise, we can able to identify the plant based on the reflected wavelengths. So that is the idea behind, or the technique behind identifying the ground objects based on these reflected values. So this is the prism, and you can see this the one sunlight or the ray is developed into 7 ways. So infrared region, what is infrared? It is infrared region covers the wavelength range approximately from 0.7 to 100 nanometers, more than 100 times as wide as the visible. Means the visible portion is very less, whereas it's 100 times more than the visible portion. Means we have the scope of utilizing 100 nanometers of wavelength information, because certain ground objects will not be properly significantly or uniquely recorded in this only 7 type of wavelengths, whereas when it is the infrared, it can be clearly identified. So for that aspect, this infrared wavelengths are more useful, because we have 100 times much wider scope than the visible wavelengths. So the infrared region can be divided into 2 categories, that is based on the radiation properties, reflected infrared and the thermal infrared. Reflected infrared is what the light, the sun energy get reflected, or thermal means what has been stored by the earth or the object, that will be that will be radiated. Reflected infrared. Actually, we have reflected infrared means it is one is which is having it by itself, it's a source of energy, whereas another one is through the other source it will be reflecting. So another area of the electromagnetic spectrum is microwave region. This is the spectrum more recent interest to remote sensing in the microwave region for about 1 millimeter to 1 meter. This covers the longest wavelength used for the remote sensing. The shorter wavelengths have properties similar to the thermal infrared region, while the longer wavelengths approach the wavelengths used for radio broadcast. Means we are still yet to use the microwaves for many more applications. We are still doing research on how to, means which are the objects that can much clearly identified. So here we see this passive sensor and active sensor. The passive sensor means when the sunlight is there during the daytime, the sensors will be passive, because it is not emanating the light from the satellite. The satellites has the capacity to emanate the sunlight and get the reflected wavelengths and record. When the sun is there, that it is called as passive sensor. The sensors will not, it will be recording only the reflected wavelengths from the sun, not by producing its own light or rays. So this is called as passive. Means when the sun is in during daytime, if the satellite covers the objects or senses the objects of the ground object, it is called as passive sensor. If the satellite covers the ground objects during night time by emanating its own light, it is called as active sensor. And what is the geostationary orbit, or where the exactly these satellites are launched or fixed? Actually, satellites are not fixed at one place. The satellites will be moving, and there are two types of satellites. There are many types of satellites, but in common, we talk most commonly used satellites are geostationary orbit satellites and polar orbit satellites. The geostationary satellites are launched to a very high altitude, and it will be kept seeing to one particular point of the ground object. Yes. If you have questions, yes, please. Hello. Is there any question? Okay. I'm not getting. Can it be bolder? See, these geostationary satellites are they will be in the sky at a higher altitude, very high altitude, 35,000 kilometers. 35,000 kilometers means you can imagine it is not, it is too higher. Why? It has to synchronize with the Earth's rotation. So the Earth rotation and this satellite, which is there in the high altitude, will be looking into one particular point. These are all these satellites which will be helpful for our television connections. So we get the television transmission or the television connection through geostationary satellites. Whereas the near polar orbit, it will be nearer to Earth. It is 800 to 1000 kilometers altitude, and it will be moving from from North Pole to South Pole. So this is called as the near polar orbit, and so both the Earth as well as the satellite will be moving. Whereas the geostationary satellites, it will be moving along with the Earth, pointing out, fixed to the one particular point. So, okay, this is all about the active and passive satellites and the geostationary and polar orbit satellites. So, let me come to the actual, what is the output that is given from this satellite, that is the polar orbit satellite. So you get earlier there was a big what obscure data that was to be sent by the satellites. Obscure means the information was not clear, thoroughly clear, because of the resolution. What is resolution means? Actually, the entire ground objects are captured, and it will be sent to the end user in the form of a pixel. A pixel is nothing but the picture element. What one pixel used to carry 120 meters of information. One pixel, very small pixel, used to have the information of 120 meters of ground data. So that was the resolution in the very beginning. Later on, it came down to 90 meters, from 19 meters to 60, 60 to 30, 30 to 15, 15 to. Now we get at a very, the configuration is so high that it is as good as our real-time camera. So I hope you are understanding, and if you have any clarification, please intercept me and I will be happy to answer to your questions. Is it clear? Hello?
Yes, sir.
Okay. So let me see, this is one simple diagram in order to give you a picture about what was the earlier satellite resolution and now the present satellite resolution. This is a township. and you can find there are some roads and there are some buildings and the small roads and big road, and there are some other kind of establishment. So we just look into it, what how this resolution has improved over time. When during the 1960s it was totally obscure, 70s, 80s, and even 90s we were using 122 meters resolution. So this is the pixel. See, now actually this is a the updated or the present road map or a settlement map, which is clearly visible to us. These are the roads and there are certain buildings and other things. If the same area, satellite data, how it looked during the earlier times, that is this image. So just you take off this and can you make out anything out of this? Because all these pixels are in different colors and it is showing something which is not that much clear. So there is no any road like or the buildings. So all there is only one dark patch which looks to be something different. But rest of the thing, the roads or the buildings or the houses are not very much clear in these pixels. I'm talking about pixels, means this one is pixel. So they are not very clear. So later on, 30 meters resolution where the pixel size gone shrinked means here in the earlier 80 meters resolution. 80 meters, one pixel carries 80 meters of information. 80 meters means it is a huge area. So in 80 meters, there can be a building as well as a small garden also. So for both building and garden, one pixel means how it can be divided. It cannot be divided. Which reflectance value is more, that reflectance value will be taken into account. The rest, the other aspect will be discarded or it is neglected. Are you following? So that was the resolution. So what happened? 30 meters, the information for 30 meters came. From 30 meters, and you can see now the roads are looking a little bit brighter. All the pixels are looking brighter. And here also some houses and other buildings are looking brighter, like creamy color or light white in color. And there are some green pixels also showing that some vegetation, whereas in the earlier it was not like that. Earlier there was nothing. So in this we can see some green patches and white and black, all some different pixels are indicating some different objects. And in a panachromatic means 10 meters resolution, it become much more clearer. And what we see in 1 meter, you can see the building and also the roads. And in sub-meter means it is 50 means we are finding the green patches in much more clearly, and there is some water body here. So this is looks to be almost a natural picture like. That means actually this is 50 meters resolution sub-meter, and you find 50 centimeters. This is a close look of a particular area, and you can find there is a rectangular which is in this. You can go on seeing how it goes on changing, means the resolution goes on changing. So you can see here it was nothing, whereas when taken it at a higher resolution, we can find there are certain what it is a aerodrome having different the flight station points, flight which will come and park here. So that is the actual building. And see, earlier the 80 meters resolution used to cover this much of area as one pixel, but now because of the sub-meter and 15 centimeters resolution, we can able to get like a photograph. So earlier the 30 meters has come down to that size, and the spot satellite 10 meters has come to that size, and now 4 meters resolution, and now we get 1 meter resolution. So from 1 meter to even half a meter resolution also we are getting. So this is how this satellite technology has grown up, and it has providing just like photograph information. So these are all satellite images only. You can see the tower, Eiffel Tower, and the aeroplane, and all the buildings and the aerodrome. Everything is seen at 30 centimeters level, 30 centimeters. And this is the stadium and the surrounding city, and you can find so much of clarity is there. So the resolutions, there are 4 types of resolutions. One is the spatial resolution in satellite. Spatial resolution means area, how much of area is covered by the satellite with how much of clarity. The spectral means what is the color bands, how much of color bands are provided from the satellite. The temporal means what is the time duration, whether it is daytime or nighttime or season wise, year wise. So radiometric resolution means color depth. So what is the tone? Means I told you there are 10 million colors. So 10 million colors means then each satellite will have its own configuration and capacity. Based on that, it will be the data will be more clearer. So we have these 4 resolutions: spatial resolution, spectral resolution, temporal resolution, and radiometric resolution. Based on this only, the satellite information will be considered to be more accurate and more versatile. So I just already talked with you about the resolution. So here the obscure condition is there. The same land we can find something which is although not clear, but which is able to means for actually in remote sensing everything cannot be through visible interpretation, visual interpretation. Visual interpretation is not at all considered in remote sensing. So it is based on the pixels. What is its the reflectance value, RN number, reflectance number? Based on that only we go on analyzing. So whether this picture is not clear to our eyes, but we can able to get a lot of data. So this is the high resolution image where the picture itself is so clear to our visual interpretation. So there are different types of satellites like communication satellites, remote sensing satellites, navigation, geostationary satellites, drone, ground, and polar satellites, and nano satellites. So all these are for different purposes. And communication, you know that it is only for our TV network and things. We have the GPS satellites. That is another set of satellites which will be 24 in number. It will be we call it as a consortium, 24 satellites consortium, and it will be providing the exact location of any object, moving or object. So applications of remote sensing, we have a lot of applications like the pre-harvest crop area production estimation. One need not to go to the field in order to get the what is the production of major crops, drought monitoring assessment and vegetation condition, flood risk mapping and flood management assessment, hydrogeomorphological maps of groundwater resources, irrigation command area, snow melt estimation, land use and land cover mapping, urban planning, forest survey, wetland mapping, environmental impact, mineral prospecting, coastal studies. So remote sensing applications are getting used to various fields, either for agricultural purpose, or even for disaster management or urban planning, whatever the activity that has to be conducted, all human activity, it has to be over the land. And when it is the land, that land information should be required. The detailed information about the land is required. So the remote sensing plays a vital role in providing a detailed information about land. Any part of the world, you can sit and get the information of any corner of the world where even the human intervention cannot be possible, where man cannot go and get the data. Even such land information is also available. So I am involved in all these crop area production estimation, drought monitoring, flood risk mapping, and groundwater assessment, irrigation command area monitoring, land use land cover mapping, urban planning, forest survey, wetland mapping, environmental impact analysis, coastal studies. So all these aspects I am involved, and I'm using this GIS and remote sensing technology for my research. So here is a very general remote sensing image which is available in the Google. And if you look at this map, you can see it is an image. You can see and you can get a good picture about what is the condition of the area of this place, and where there is sand or desert. These are the desert, and where there is light sandy kind or the little brownish kind of a thing, that is moderate, and where you find green, that is good land or well drained by rainfall. So all green patches are good climatic area. Good climatic area means good rainfall. And you can see in India, there are only small patches of green land is available in the western Ghats, and there are certain hillocks on the eastern side, and the eastern Ghats have got certain vegetation, and the Himalayas and the eastern Himalayas. The rest of the land is having totally a semi-arid to arid kind of a condition. Here, this is totally desert, and most of the land is having a arid to semi-arid condition. So whereas here you can find in China, it is most of the land is under semi-arid condition and desert. And when you look at this map, it is quite good to have visual interpretation, which land is having more land carrying capacity. What is land carrying capacity? How much it can provide shelter, how much livelihood it can provide. So this is the deserts of the world, and you can find where the deserts are there, and where the green evergreen forests are found, and where the snow cover. These are the satellite. Before the satellite images, it was not. We were not able to have the entire clear picture of the whole world. So we can now get very good information for the entire world. So this is India again, and you can find where are the high temperature spots are located. This is again from the satellite images, and where the cyclones takes place, and in which direction it comes, and where the rainfall will be more, and what are the measures that has to be taken place for which area. That application can also be done, and this is for agriculture, water resources. And you find the crop management, where the crops are grown, and what is the type of a crop, and you find which are the places having extremely water stress, extreme water stress areas in India. And you can find almost all parts of India except the few eastern side do not have, that is which comes under the Ganga and Brahmaputra area. They do not have water stress, but most of the India has got water stress. And you can find the soil moisture map, and so each information is obtained from the satellite. So the whole country, we know, like for the entire India, what is the situation, whether groundwater situation or water stress situation or soil moisture situation, arid situation. So all flood situation, everything can be obtained from the satellite. And this is the flood situation of India. This is high temperature and hot waves zones of India. So which are the places which get hot waves? So based on the satellite data, we can make lot of research, and a scientific approach is there, and accurate output is there, and we get a good solution out of it. That is the major the advantage of satellite information, because by using this satellite information, you can means see, either you can get it for 1 day interval, or 1 month interval, or 1 year interval. So different seasons, different days, different months, all kind of a possibility, means you can make lot of analysis using the temporal data of satellite data. So coming over to the GIS, Geographical Information System. What is Geographical Information System? It is nothing but the information of a particular land. So every object is located online, whether it is cultural object or the natural object. The cultural object, like this building is located on a land, and the natural object like a tree or a lake, Kukreli Lake. So this is the natural object, but without having any information, it is of no use. When we tag or when we link certain information, what are the information that is related to it, then it will become more informative and more useful. So how to link when it becomes the geographical information system? When it becomes geographical information system means, first of all, the location should be, it should be tagged to its geo-coordinate system. Geo-coordinate system means what is the latitude and longitudinal location of that particular building. Say, for example, your house is located in some city, and what is its latitude and longitudinal coordination, so that it can be correctly marked on the map. So also the natural object. So there is no difference between natural and cultural, because all information is very much useful. So when we provide a locational information for a natural cultural, that is the foremost thing, because unless and until you identify or fix a location on the world coordinate system, it will not have any kind of use. So once if it is located, or when it is marked on exactly to its ground coordinates on a map, so what is the next thing? We need to provide the attribute data or the information related to that building. Say, for example, if it is a house, who is the owner of house? How many building rooms are there? What is the total built up area? So the likewise we can give when it was built. So what is the type of material used? So anything which is related to that building can be, we can build a database. So that becomes much more useful. First of all, locational aspect. After locational aspect, you are providing what is the information or the data that is related to that location. So if it is a, say for example, if it is a tree, what type of a tree? It is a mango tree. What is the size of the tree? What is its production? When it was planted? Hello? Is there any? So are you able to understand me? Because I'm just going one-sided and I'm not getting any response, either any questions, or if you have any questions, it will be good if you ask questions to me, so that I can able to deviate from my own talk and explain according to your requirement.
No, sir. At the end of the session, also maybe questions.
What? No, I didn't get.
At the end of the session, maybe question will be asked.
Okay, end of the session. Okay, fine. So shall I complete it in 3:15 is the session is going to end, isn't it?
Yes, sir. Yes, sir. Yes, sir.
3:15. Now
Yes, sir.
3:04. In another 6 minutes, I'll complete, and so that you can ask questions. So let me how this remote sensing and DS are integrated, because see, remote sensing acts as a source of data provider. Geographical information is a platform, a software. It is a software. Geographical information system is a software. It is a platform where the remote sensing data is utilized in order to make analysis, whether to find out which part of the land is good. Say, for example, I wanted to grow strawberry. I know that strawberry is not a natural plant grown in Mysore district, but I want to see if is there any place which is having a good congenial atmosphere to grow strawberry. So I can make the data analysis using the remote sensing data as well as remote sensing data. I can make analysis and find out which are the spots where almost nearing, if there are some 10 criteria, say for example, the temperature should be about 25 degrees centigrade, the humidity should be about 50, and the rainfall should be about some 35 millimeters. So if there are some 10 conditions, out of 10 conditions, if there any place which is fulfilling 8 conditions, I can think over, okay, let me use this spot for cultivating strawberry, and the other 2 conditions I can create it by my own. So likewise, we call it as the site selection analysis, crop suitability analysis, which crop is suitable for which spot. And the site suitability means if I want to start an industry or a school or a bank, which will be the best suitable place where the business can happen. So that kind of analysis can be done with the GS platform. So even if you want to find out where the forest fire can occur, what is which place will be susceptible for forest fire, that analysis can also be done, because I am getting a very good data from the satellite images, satellite about the forest, and based on the different criteria and different type of logical analysis, I can able to find out which is the most susceptible place for forest fire or flood mapping. So, there are various applications which are combined both with the remote sensing as well as the GS. GS is a platform of analysis, whereas remote sensing is the provider of data, because all forest data or agriculture data or temperature data or groundwater data, all data will be provided from the remote sensing. And when the data is taken into the GS platform, and we can analyze and we can able to produce a beautiful or very useful map. So in this map, you can see there are three upper 3 images and bottom 3 images. So it is the MSS Landsat American satellite image, and 1997, you just see what was the type of land use and what happened in 1989 and 2002. So yeah, when it comes to 1977, you can see there are very less green patches, but now in 1989, green areas has increased, and there are certain brown patches has increased along with the increase of the pasture land. So here you can find the forest area is very less, and agriculture land has been increased, and pasture land has been increased, and desert land has also increased in 2002, and this is the Gobi Desert region. So what has happened in the Gobi Desert from 1977 to 2002? This kind of analysis can be done using GIS and efficiency. So population change can also be studied. What is happening in population means regarding the population in Las Vegas, 1964, 72, 86, 92. So coming over to my own research work, earthquake susceptibility zone in Mysore city. So I have identified these are the spots, these are the most vulnerable spots of earthquake in Mysore city, where there will be greater damage of life and property. And desertification I had done, and based on the desertification, I can show you the final output map. So these are the most susceptible already. It's under beyond the control, beyond we cannot bring back. We can bring back means it requires minimum 30 years for continuous. We had to have a major policy, and we had to operate on this land for 30 years. So the Chamnagara belt and the Chitradurga Raichur belt, and this is the Belgaum region. So which are all the most driest and which is under dry condition. Desertification means the land which was under humid conditions transformed into subhumid conditions, subhumid to semi-arid, semi-arid to arid, and arid to desert. So these are all the work, and this is the urban planning. So Mysore city vision 2100. How urban should be? Mysore city should be planned for 2100, up to 2100. That is, I have made some 4 models: the subsector model, priority model, and other models. And also I had done Uttarkashi landslide mapping, susceptibility mapping, and damage inventory. So these are all the a few research works that I have done, and there are also certain work done which is going on. The identifying the most arid spots of Chamarajanagar and Gundlapette taluks, and also the groundwater depletion, status of groundwater depletion in the mid-Kabini River basin. So there are many such works are being taken over using GIS and remote sensing technology. So with this, I just put an end to my talk, and if you have any questions, please go ahead and I will answer to your questions. Yes, please.